Okay, so here's the new material regarding quadratics and graphing. Let's say I wanted to sketch a graph of x squared minus 2x minus 15. The problem is it's not in a format that I can figure out a horizontal shift, a vertical shift. I don't know if it's wide or narrow, but it is in standard form. So what I can do is I can factor this. And so when I factor x squared, that becomes x and x. 15, I have some options. I got 1 and 15, or I got 3 and 5. Let's go ahead and choose 3 and 5, negative and a positive. So when I check this here, that gives me 3x. This gives me negative 5x. So in fact, I do get negative 2x. So this is factored correctly. Now, to graph this, let's take advantage of the fact that we know that if I set this equal to 0, x plus 3 times x minus 5, if I set that equal to 0, that means that x plus 3 must equal 0 or x minus 5 must equal 0. So x in this case is going to be negative 3 and x is going to be positive 5. In other words, there are two values of x that cause the output to be 0. And those two values are going to be x equals negative 3 and x equals 5. Okay, well, what does this mean in terms of a graph? Well, let's think about on a graph, where is the output equal to 0? The output is equal to 0 on the x-axis. That's when the y value is 0. So if I have negative 3, 1, 2, 3, I know that at negative 3, this is going to have an output of 0. And I know at positive 5, we're going to have an output of 0. So if I just wanted to sketch this parabola, just a rough sketch, I know that it's going to open up. I know it's going to open up. Why? Because the leading coefficient here is a 1, so that's positive. It's positive 1. It's going to open up, and a brief sketch of this parabola is going to look something like this. It's going to come down. I'm not exactly sure how far it's going to come down, but then it's going to cross through these points at negative 3, negative 5. But we can use that to our advantage when we look at the Desmos activity. If we go back to the Desmos activity and we look at this graph, this slide right here, challenge number 5, if I want the red graph to go through this point, 3, 0, and this point, negative 4, 0, then I can simply take this equation and I can write it as x plus 4 times the quantity x minus 3. And that's going to cause this red parabola to go right through those points. Now, I want the blue parabola to go through the same points. I notice there's a negative 2 out in front. That's fine. That just means that it's going to open down and it's going to be a little bit more skinny. But if I change this to an x plus 4 and I change this to an x minus 3, it also goes through the points. But the parabola opens down. And then with the 1/5, it's going to be wider, but I can change this to an x plus 4 and change that to an x minus 3. And again, all these parabolas are going to go through the point negative 4, 3, because negative 4 and 3 are the values that cause the output to be 0. And that's the connection, that's another connection in graphing parabolas.